This is section 6.6, which is vectors. I'm going to let you know right now it's been about, I don't even know how long since I have done vectors, so we shall see how this goes. All right. Quantities that involve both a magnitude and a direction are called vector quantities or vectors, and quantities that involve magnitude but no direction are called scalar quantities. So what do they mean by magnitude? Magnitude is like how big it is, the distance between the beginning point and the end point, and the direction. Are we going straight up? Are we going straight down? So this would be an example of a vector that's going up and to the right. A line segment to which a direction has been assigned is called a directed line segment. We call the initial point where it starts, in this case P, and the terminal point is where it ends, in this case Q. The magnitude of the directed line segment is its length. And we use these, they look like absolute values, but there's two of them. And so that is referring to the magnitude, which is, again, the distance between the initial point and the terminal point. So a vector is a directed line segment. So if we have a vector v, if we want to indicate v, if we would just want to write it, we would put a little line with an arrow on one end, pointing to the right. To indicate the magnitude of the vector, we would put like this, or sometimes we would do that. So there you go. So magnitude is the double bar. Vectors are equal if they have the same magnitude and the same direction. And then we would say these two vectors equal each other. So if we look at this example right here, they both have the same length or magnitude, and they are both going in the exact same direction, aka they're parallel. Then we would say that they are equal to each other. These two have the same magnitude, but they're not going in the same direction, so they are not equal to each other. These two are equal to each other and parallel, but this one's going up and to the left, and this one's going down and to the right, so these are not equal to each other. They do have the same magnitude, but they're going in opposite directions, so they would not be equal to each other. So V is not equal to W. And then these two are going in the same direction, but they don't have the same magnitude. They don't have the same length, so they would not be equal to each other. Is not equal to W, and V is not equal to W, but V is equal to W in this case right there. All right, how can we show that these two vectors are equal to each other? So if it's on a rectangular coordinate system, they would have to have the same distance and the same slope, and have to go in the same direction. Okay, so they are both going up and to the right, so that helps. but we need the magnitude. So the formula for magnitude, which apparently is not on here, is, I'm looking for it. Okay, so the magnitude of V, this is the formula, is equal to the square root, no, we're just using the distance formula, of let's call this one the first one and this one the second one. So we're going to take the second x value, which is -2, subtract the first one, plus the second y value, subtract the first one, which is equal to -2 plus 5 plus 4, which is 3 squared plus 4 squared, which is the square root of 9 plus 16 is 25, which is equal to 5. So we need to do the same thing for this one. So the magnitude of u is going to be second x, which is 5 minus 2 plus 6 minus 2, 3 squared plus 4 squared, which is going to be 5. So they have the same magnitude. And now let's double check the slope for both of them. So the slope for u is going to be 6 minus 2 over -2 subtract -5, 4 over -2 plus 5, which is 4 over 3. And the slope, this is slope of v is, oh, I reverse these. That's u and this is v. Yeah, this is u and this is v. Sorry about that. 6 minus 2 over 5 minus 2 is equal to 4 over 3. So they have the same slope, so they're going in the same direction. They have the same length, and so there you go. They are equal to each other. There's something called scalar multiplication. Scalar multiplication is we take a number and multiply it times the vector. So if you look at v and then you look at 2v, notice it's twice as long. This would be half as long, but they are still going in the same direction. So this would be 1/2 v, and I need to pause. Give me just 1 second. Okay, sorry about that. There was somebody at my door. Okay, so let's take a look at this one. Oh, never mind. Okay, so it was negative, I think, 3/2 v. So yes, we had a scalar, so it was 1.5 times, but it was negative. So what happened when it was negative? So instead of going up and to the right, it ended up going down and to the left. All right. K is a real number. V is a vector. K times V is called a scalar multiple of the vector. The magnitude and direction The magnitude would be the absolute value of k times the magnitude of v. And the direction, if it's positive, it's going to go in the same direction. If it's negative, then it's going to go in the opposite direction. Okay, if we want to add two vectors together, so we would write it as u plus v, and u plus v is called the resultant vector. If we want to show it geometrically, you would go, so if we take u right here and we add v, we place v at the end point of u, the terminal point of u. So the initial point of v, right there, is the same as the terminal point of u. Okay. Then u plus v, we go from the initial point of u, and I can't go back, doesn't let me go back. We go to the initial point of u, right there, and then the terminal point of v. So that would be the result, the u plus v. All right, if we are subtracting, it's the same as plus a negative. Let's see. Okay, so here is v right here, and here is u. Those are my initial vectors. So we're going to add a negative. Okay, so we're going to make this negative, which means it's going to go in the opposite direction. So here's my negative u. But I need this repositioned so that it is at the terminal point. So the initial point is at the terminal point of v. So I'm going to shift this up, and here is my negative v. So here I have u plus a negative v, and we go from the initial point of v to the terminal point of u. Yeah. Yes. Okay. Unit vectors. Unit vectors, remember the unit circle? We go out 1 unit and we draw a circle. Well, unit vectors, we go out 1 unit and we draw a vector. We call I the unit vector that lies along the x-axis, and j the unit vector that lies along the y-axis, positive y-axis, positive x-axis. Any vector can be represented as a scalar multiple times I plus a scalar multiple times j. So if we start at the origin and we go up here to point P, which has this x and this y value, we would multiply the I times this number and the j times this number. So we're going out this many units along the I direction and this many units up in the j direction. The sum is called a linear combination. The magnitude would be the square root of a squared plus b squared, because remember the distance formula, we would do a minus, starts at the origin, b minus 0. Okay, so that's just a squared plus b squared, the square root of that. Sketch it and find the magnitude. Okay, so in the I direction you go out 3 units, and in the J direction you go down 3 units, and so it would be that. The magnitude is going to be the square root of 3 squared plus negative 3 squared is the square root of 9 plus 9, which is the square root of 18. Simplify that. 3 square root of 2. The vector with the initial point and terminal point. Okay, so we take the terminal point minus the initial point, and the terminal minus the initial. All right, so this is our initial point, and this is our terminal point. We are going to take our terminal minus our initial for our x's, and that's going to go with our I, and our terminal minus our initial, and that's going to go for the y's, and that's going to go with our j. So negative 3i minus 4j. If we want to add them or subtract them, we would add the a's to get the I, add the b's to get the j, subtract the a's to get the I, or the multiple of times I, the scalar multiple, and subtract the b's. All right. Okay. Find the following. We need v plus w, and that would be, so v plus, so we're going to do 7 plus 4, and 3 plus negative 5, which is 11i minus 2j. If we subtract, we're going to have 7 minus 4i, there's my I, plus, is it plus? I hope it was plus. V3 minus a negative 5. That should have been a j. Eesh. Okay. 3i plus 8j. Scalar multiple, we multiply both the a and the b. All right, so 8 times v would be 8 times 7i, 8 times 10j is 56i plus 80j and minus 5. So we're going to multiply times negative 5 and negative 5. So negative 35i minus 50j. It has been so long since I've done vectors. Okay. The 0 vector, we use 0 to indicate it. Notice the vectors are always bold. I don't know if I mentioned that. I did not mention it, but when we type them, it's bold. The 0 vector has no direction, and the magnitude is going to be 0. We would use 0 times I plus 0 times j. It does have the commutative property of addition, so you can change the order. That's perfectly fine. It does have the associative property, so you can group the first two or group the last two, meaning you can add these first or you can add those first. That's perfectly fine. The additive identity, if we add 0, still gives us u. If we add a negative, that will give us 0. A negative of the same thing. Scalar multiplication, we can either multiply the scalars first, or we can multiply times u and then multiply times c, so it is associative. Notice it did not say anything about commutative. We can distribute, and that's fine. We can distribute this way as well. 1 times u is just going to be u. 0 times u will be 0. And the magnitude is going to be the absolute value of the scalar multiple times the magnitude of v. Okay. Unit vector has a magnitude of 1. This is the unit vector, so we take any vector and divide it by the magnitude of that vector, and that will give us the unit vector that has the same direction as v. Okay, so this is v divided by the magnitude of v. That's going to be our unit vector. And all right, so the magnitude of v. Okay, magnitude would be the square root of 4 squared plus negative 3 squared, which is equal to the square root of 16 plus 9, which is the square root of 25, or the magnitude is 5. So to find the unit vector, we would take our v and divide it by 5. So we would have 4/5 I minus 3/5. That should be j. And this is going to be the unit vector. And then verify that it has magnitude 1. Okay. So we would 4/5 squared plus negative 3/5 squared. This would be 16 over 25 plus 9 over 25, which is 25 over 25, which is the square root of 1, which in fact is 1. So the magnitude of the unit vector is equal to 1. We can use vectors, or we can write vectors in terms of cosine and sine. Okay, so if theta is the angle, remember cosine of theta, that represents the x value, right? And so that would be our x value. And the magnitude of the vector. So we're going to take the magnitude times the cosine of that angle times I, and the magnitude times the sine of that angle times j. So yeah, fun times. jet stream is blowing at 60 miles per hour in the direction north 45 degrees east. Express its velocity as a vector in terms of I and j. Okay. Hold on. So, yeah, I will. Sorry about that. So the north 45 degrees east, I didn't intend for it to click through, would be this angle right here is 45 degrees. Because this is 45 degrees, that makes theta 45 degrees. So theta is 45 degrees, or pi over 4. So theta is, I'm just more familiar with radians than degrees. The magnitude is the same as the velocity is the same as the how fast the jet stream is blowing. So the magnitude would be 60. So the vector would be 60, the magnitude, times cosine of 45 degrees, which I'm going to do pi over 4, times I plus 60 sine pi over 4 j. Okay, so 60, the cosine of pi over 4 is the square root of 2 over 2, and 60 sine, the sine is also the square root of 2 over 2, j. This goes in there 30 times, so 30 square root of 2i, 30 square root of 2j would be the velocity vector v. Two forces of magnitude 30 and 60 pounds act on an object. The direction of force 1 is north 10 degrees east, and the direction of force 2 is north 60 degrees east. Find the magnitude to the nearest hundredth of a pound and the direction angle to the nearest tenth of a degree of the resultant force. So the first thing we want to do is write both of these as vectors. All right, so we have, make sure I'm actually writing instead of clicking. We have, this is north 10 degrees east. So this is 10 degrees, so this is going to be 80 degrees. And the magnitude is 30. So vector 1 for force 1 is going to be, what is it, 30 cosine 80 degrees I plus 30 sine 80 degrees j, and I'm just going to leave it like that. And then force 2 is north 60 degrees. Okay, so this is 60 degrees and this is 30 degrees. So it's going to be, and the magnitude is 60. So 60 cosine 30 degrees I, 30 sine, 60 sine 30 degrees j. Okay, now when they are acting together, so we have this vector, which is f1, and this vector, which is f2. If I were to shift this f1 if I were to translate it, it would down here. Then I would have these two added together, which would be this one right here. In other words, you add the two vectors together. So f1 plus f2. I'm going to write this as a decimal. I'm going to do that first. And I'm going to pause the video while I do that. Okay, so I plugged this into my calculator and I got 5.21. This into my calculator, 29.54. Same with these two. I got 51.96i and 30j. And then when you add the two together, this is what you end up with. Find the magnitude and the direction angle to the nearest tenth of a degree. I'm going to cross my fingers and hope I have room on the next slide. I have room for the magnitude. So it would be square root of 57.17 squared, 59.54 squared, and let me just do that real quick. Squared plus 59.54 squared, and then take the square root. The magnitude of f1 plus f2 would be 82 magnitude to the nearest hundredth of a pound, 0.54, and the direction angle. Let's see if I have room on the next slide. All right, so we know that the magnitude times cosine theta is equal to the A value, and the magnitude times sine theta equals the B value. So our magnitude was 82.54 for the resultant force. They call it F. So for F, you're going to have 82.54, which is the magnitude, cosine theta I plus 82.54 sine theta j. Okay, and we are trying to find I forgot what the I and J were. Hold on. Okay. So I've looked it up. It was 57.17 I plus 59.54. Okay, so this is the same as this. So we can use that information to find theta. So 82.54 times the cosine theta is equal to 5717 divided by 8254. 8254, and so cosine inverse of 5717 8254 is going to give me theta. And we can do the same thing with the sine. So the sine inverse of, we're going to use 59, 54, 82, 54 is going to give me theta. So give me a minute to put that in my calculator. Never mind, I don't have those on my calculator, the one I actually have handy. So anyway, that's how you would find theta. You just have to punch it into the calculator. Maybe I have it